All right. In this module, we're going to look at the Gaussian error function, or error function for short. And again, that's the ERF term we saw in the previous example. So going back to the solution to the PDE for semi-infinite non-steady state diffusion, we saw that we had this expression where the concentration as a function of position and time was equivalent to the concentration term was equivalent to 1 minus the ERF of this term. And I said that's Gaussian error function, and it had this expression here that defines the error function. So this is, a lot to deal with for this calculation. So instead of having to solve for this each time, what we do is we tabulate those values. So if we go forward, you'll see that the table, and I believe this should be 6.1 in the diffusion chapter. So I apologize if the number was different elsewhere. But this is the tabulation of the error function values. So it's basically looking at the error function, or ERF, of z. And you can look at this in two ways, right? If you know the value of the term inside of the error function, right, then you can look at these values and then go over here and find out what the error function of that value is. Or if you know what the error function of z is equal to, then you can determine what z is going the other direction. So there are problems where it may work in either direction. So you have to keep track of that in this case. One thing I'll say is I've kind of shown you here that there's multiple columns. So it goes from 0 to 0.5 and then starts over again at 0.55 up here. So basically everything on the left side here is one combination, and then it starts over and then it starts over. So there's actually 3 columns of z values. So when you're looking at this table, you might kind of keep track of that. That's a very common mistake, is to maybe get these mixed up and relate this one to this one over here. But it's z and then the ERF of z, and then the ERF of z for all of these. So this is tabulated, and this is something that we can look at. And for our diffusion questions, we can use this table instead of having to actually calculate that integral that we saw in the previous expression. So we can just use these directly in that case. If your value isn't close enough, you may have to do a linear interpolation between points, right? So if you have a z value of 0.075, right, then that's between these two values. So you'd want to interpolate the value of these to get a more accurate value. All right, so you may want to kind of understand what this function looks like. And so this is plotting the ERF of x here as a function of x. And so we're going to be mostly interested in what happens from 0 to 3, right, the positive values. And so you see here that it goes up and then kind of plateaus and asymptotically to 1. And so we are looking at 1 minus the ERF. And so if you look at those, and again, we go back to the previous expression, you'll see that basically this is 1 minus the ERF. And so they look very similar, and they asymptotically go to that C naught value. So that's what this error function is, and we're going to use these tables in our problems relating to non-steady state diffusion.